Welcome back to the next part of our topic, that is converting kilometers to nm. Nm means nautical mile. Nm means nautical mile. And the equivalence is that 1 nautical mile is equals to 1.853 kilometers. So this relationship can be used to convert either kilometers to nautical miles or nautical miles to kilometers. For example, the radius of the Earth is 6,370 kilometers. So if 1 nautical mile is 1.853 kilometers, what about 6,370 kilometers? So using the ratio, we'll have 6,370 divided by 1.853 nautical miles. So you can finish that and write the answer in nautical miles. So I can see it is 4,018.17 to 2 decimal places. So that is the relationship between a nautical miles and kilometers. All right. The next part is speed. Speed, the formula for speed is distance over time. But when the distance is nautical miles and the time is in hours, then we have a unit called knot. The common unit we know is kilometers per hour or meters per second or centimeters per seconds. But this knot, one knot, means distance in nautical miles over, not one knot. Knot means distance in nautical miles and time in hours. It's not 1 nautical mile, it's what is a knot. All right? Good. So that is distance. So that is speed. So we can look at an example. Say, if the distance moved is 4,000 nautical miles and the time taken is half an hour, then the speed, which is distance over time, this distance must be in nautical miles and time must be in hours. Then it will be 4,000 divided by a half, which gives us 8,000 knots. 8,000 knots. Okay, which because this was nautical miles and this was hours. So nautical miles of hour is the knot. So that is speed in knots. All right, going back there, then we look at what we call change of longitude and its effect on time. Change, what that means is that when you move to the west, you lose time. When you go to the east, you gain time. For example, in this diagram, it's shown that any 1 degree moved to the east, 4 minutes is gained. If you move yet another degree, you gain 4 more minutes. If, however, you move to the west, if you move 1 degree to the west, you lose 4 minutes. So that 1 degree is equivalent of 4 minutes in terms of time gain or time loss. That's what we said here. 1 degree to the east adds time by 4 minutes. 1 degree to the west subtract time by 4 minutes. So let's assume that we have a point which is at 40 degrees east. And at that point, the time is 12:05 p.m. So at 41 degrees east, we have already moved 1 degree to the east. and therefore we are going to add time by the equivalent of the time for 1 degree, which is 4 minutes, so it becomes 12:09 p.m. If I'm still at the 40 degrees east and I move to 39 degrees east, that is, I move 1 degree to the west, I will lose 4 minutes, so that when it is 12:05 p.m. at 40 degrees east, it will be 12:01 p.m. at 39 degrees east. So looking at an example, say for example we have 3 points. Point A is 50 degrees north, 30 degrees east. Then we have a point B, 50 degrees north, maybe 25 degrees east. Then we have a point C, 50 degrees north and 20 degrees west. So those points are, say this is the prime meridian. So we have that one, 20 degrees west. We have 25 degrees east, and we have 30 degrees east. So assuming that the time at B is 12:05 p.m. Alright, sorry, I had written here 20 degrees east instead of 25 degrees east according to the example. Alright, now if we assume that the time at B is on the 25 degrees, let's put the 50 degrees north, so that we have, this is point C, this is point B, and this is point A. If it is 12:05 p.m. at point B, moving towards A, it's moving further east, and that means we gain time. So how much time do we gain? Between 30 degrees east and 25 degrees are 5 minutes. So the time gained is 5 degrees times 4, which is 20 minutes. Therefore, at A, it will be 12:05 plus 20 minutes, which it will be 12:25 p.m. Between B and C, remember, there is 25 degrees between B and the prime meridian, and there is 20 degrees between the prime meridian and C. So the total time between the total angle, not time, between B and C is 25 degrees plus 20, so 45. So time lost will be 45 degrees times 4, which gives us 180 minutes. It's the equivalent of 3 hours, isn't it? 3 hours. So the time at C will be 12:05 less 3 hours, which will be 9:05. This was PM, so this will be AM. So time at C, and this is time at A. So that is how time changes with change in longitudes. I think what we do now is comfortably tackle exercise 6.1, exercise 6.2, and exercise 6.3 of KLB Mathematics Book 4, either edition 3 or 4 or 5. And that marks the end of the explanation of our notes on longitude and latitudes. I will be able to provide the answers once you are done, and I think we can do it in the next 3 days or so. Thank you very much. Have a nice time.